second part to this video, but firstly, let's just go over A part. So to sketch a graph of each quadratic function, A, y equals negative 2x squared plus 10x minus 14. The first thing I like to do when I see this kind of question is I want to find out the discriminant. Now I know that this thing is going to be opening down, but the discriminant can tell me, does it have roots or not? Because if it doesn't, there's no point in checking for roots. So we have the discriminant being b squared, which is 10 squared, minus 4 times a, which is 2, minus times negative 14. So that equals 100 minus 114. So some of you guys got this wrong on the test too. There are 3 negative signs, so I know that the sign in front is going to be negative. 2 times 4, 4 times 2 is 8, times 14 is 114. All right, Mrs. Woodyard interjection. 4 times 8 times 14 is 112, not 114, but it doesn't really matter because the discriminant is still negative. Just wanted to clarify. That's going to be a negative number, less than 0, so no roots. So it's opening down, and I know that if I were to just draw a little sketch, I know that the vertex is going to be below, okay? There are no roots, so then it never touches that x-axis. So then what I want to do with this one is I want to complete the square, because, or use completing the square to help me out here, because then we can get the vertex right off the hop. Another thing that we should note is the y-intercept is negative 14, because right here is our c, negative 14. Alright, so the first thing we do is we want to pull out that negative 2. So then we're left with x squared minus 5x. And then we're just going to say minus 14 out front. We got to think of what can we do to this, what can we add and subtract to this to make it a perfect square trinomial. Y equals negative 2, x minus 5x plus, remember, to get that we go, to get our c term in that, squared. To get our c term here, we go 5 over 2 squared, so that's going to be 25 over 4. Minus 25 over 4, minus 14. We want to take this negative 25 over 4 out, so what we need to do is we need to multiply negative 2 times negative 25 over 4. Y equals negative 2, x squared minus 5x plus 25 over 4. And then here, negative 25 over 2 over 4 minus, negative 25 over 2 times negative 2 is just going to be positive 25 over 2 minus, and what I'm gonna do right off the hop is I'm just gonna make this into having a common denominator. So I'm gonna say minus 28 over 2. Okay, 14 is just 28 over 2. This turns into negative 2 times x minus 5 over 2 squared. Guys, I want you to take notice of this. See how these two things are the same? That's important, and it's a significant time saver, actually. And then I have minus 3 over 2. So I can look at this and say, I know my vertex is going to be at 5 over 2, comma, negative 3 over 2. So it's going to be at positive 2.5 and then at negative 1.5. I know that my y-intercept is good, or is negative 14. So look at this, folks. I'm just going to graph it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. So this is 2, and this is positive 2. So I've made known my my scale. So the vertex is going to be positive 2.5, negative 1.5, so it's going to be here. I know that my y-intercept is going to be at negative 14. And if I really wanted to be a smarty pants, what I would do is I would just say, okay, so then I'm just going to add 5 because the difference between the x-axis, the y-axis and the vertex is 2.5. So I'm just going to 1, 2, 3, 4, 5. I know that my next point is here. Now guys, if that confused you on a test officially, I just need to have 2 points, especially in this situation when there are no roots of the equation. So then what I can do is I can just connect the dots. And this right here is my y equals negative 2x squared plus 10x minus 14. And we're done. So it's pretty easy actually when we don't have any roots because we don't need to find the roots. We don't have to find the x-intercepts. The next question though, you bet your bottom dollar, we're going to have to find out what the roots of that equation are.